All right, so this is a story I want to bring here today about the successful, I would say, I'm a little bit biased, but I would say very successful Oracle to Postgres migration. This is the story about the migration we did some months ago. Actually, it was a long-running project for BlackBerry. I'll speak a little bit more about BlackBerry, because it may sound like a little bit old, but it's not that much. So, first of all, a little bit about myself for those of you who don't know me, because I know a lot of people that know me here. My name is Álvaro Hernandez in Spanish, or Álvaro Hernandez in English, or you can call me whatever you want. I'll probably answer anyway. I am the founder of a company called OnGres, which, as you can maybe infer from the name, that's Postgres-related things. Some of them are crazy stuff that we come up with, like Project ToroDB, where we developed a solution to migrate in real-time data from MongoDB to Postgres, while in the process structuring automatically the data, so transforming from JSON documents kind of to relational tables, like if you were a human DBA doing this design. And we are very integrated in Postgres community. I am myself a speaker at many conferences per year. Some of the people who are here also are frequent speakers, know me for that. And I think this is like maybe my 10th talk this year, something like that. So, enough about myself. Here's my Twitter address. Just ping me anytime. I'm also available by email, whatever you want. So, first of all, why migrate from Oracle? The first reason is very obvious at this point, that you don't want to keep paying for Larry's boat, which in more common terms could be cost. For those of you who run Oracle, do you know how much do you pay for that? Your companies pay for that? Yeah? No? Huh? You don't care. Well, this is a fair enough answer, that you don't care. The management typically cares, right? And that time where people were saying, you know, you will not get fired by, you know, contracting IBM, or you will not get fired for buying Oracle, right now turns into, we don't want to keep paying these millions. And sometimes it's many millions. Do you know how much list price an Oracle license cost? $50,000 per core, basic license. You want rack, you want in-memory option, you want other stuff, keep adding to the sum. So you very easily get to the thousands of $100,000 or more, or even millions. Of course, then you get some discounts, but it's still very, very expensive. The second reason is Men in Black. Basically, the licensing terms of Oracle license are quite strict, and so strict that they could basically knock your door, the door of your office, and you need to let them in and start touching your computers and checking what do you have in those. We had one customer that when this Man in Black came to his office and started asking, everything was right on the main server, but then they asked, oh, where do you store the backups? Oh, in that NFS NetApp file server. Do you have an Oracle license for that? No. License point 11.4.2.3.4. You need to pay a license for the place where you store any file derived from Oracle. Another 50K. And this is in the Oracle license, you're accepting this. So also management are not happy about this. There's also other kind of reasons. And it's, some people don't want to store data on a proprietary relational database. Think of actually Larry's own words supporting the NSA. The NSA is spying on others. And some organizations, especially governments, are not comfortable with this. Some maybe, that's a fair choice. But some are not. So this is also a concern. Last but not least, Oracle is not available as a managed solution on most cloud environments. And this is a showstopper for also many organizations who want a managed offering, a managed relational database offering. So for all these reasons, there's a real trend nowadays of Oracle to Postgres migrations. And the reason why these migrations are mostly going to Postgres and not other open source databases is that Postgres is probably the most natural fit for an Oracle migration. Significant part of this is a PL/PG/SQL language, a procedural language that comes with Postgres that is very similar to Oracle's PSQL. It's not the same, and I'll touch this point later, but it's very similar and makes the transition smoother, as well as the rich SQL implementation. Other open source databases, even though one of them, MariaDB, has initial support for PL/SQL, Oracle's PL/SQL, it is still very basic support. And then the rest of the features, the rest of the SQL that comes with Postgres makes it a much better fit, at least as of today, to Oracle. So, this is the background about these Oracle migrations. A little bit about this project itself, for you to understand the dimension of the project. There is a great talk, which I would recommend you to watch, by BBM's CTO, Mohan Krishnam, that did a Google Next this summer. And it's a really great talk that focuses on the whole migration for them, not only the database part, specifically the networking part and the application layer. It's a great talk. I would definitely recommend it to you, and it's recorded on video. So BBM, or BlackBerry Messenger, is not what you would call your father's BlackBerry. Yes, we all remember probably the initial BlackBerry. Now BBM runs on Android, runs on iOS. It is a very modern platform. It is being continuously developed and improved. So don't think of this old BlackBerry Messenger that you require to run on a BlackBerry. It is no longer the case. It is actually becoming more of a platform. It's similar to WeChat in this respect. You could even do payments from BlackBerry Messenger, from Android, from iOS. So it's not that this old legacy that you may think of. And it's very big. It's more than 150 million users. Certainly it's not WhatsApp, but it's actually the size, correct me if I'm wrong, of Telegram, more or less, in terms of user base. So it's a significant amount of users there. And we were tasked to help them migrate their infrastructure that supports all this usage and all these users from Oracle to Postgres. Some facts about this platform: they have 6,000 servers. Of course, this includes not only production environment, but testing and staging environments, but it's a significant amount of resources. And the challenge was not small, not only because of the sheer size of these numbers, but because they were on-premise running on data centers in Canada. And their main user base is in Asia, mostly Indonesia. So they want to migrate this on-prem in Canada to Google Cloud Platform on Asia. And that adds instantaneously 250 milliseconds latency with the really good pipes that Google had. You can imagine this makes things even more complicated. The database itself do not contain the messaging. Messaging is actually running on Cassandra nodes. They have like around 400 Cassandra nodes just only for the messaging part. But the database, the Oracle database, contains the authentication and authorization of the user. So it's an absolutely critical part of the service. And it's a database measured in several terabytes, and it's very heavy traffic in terms of OLTP load. So it's still a significant challenge for the database part. Now, what are their requirements for this migration? Well, first of all, no downtime or near zero downtime, very small downtime. This is understandable. Otherwise, the users would be heavily disrupted, right? No data loss. This obviously sounds obvious, but it's not that obvious because it's not easy, especially on a cross-ocean link like this. And also, they wanted data to be checksummed. So to really make sure that there's no even a bit lost. No even one single user may have any problem logging in after the migration. And obviously, with the complexity of the application, this required also a lot of testing, long testing period, even though the migration would be performed slower. Actually, the whole migration for BBM took almost 18 months, apart from the database part. Last but not least, they wanted a full stack Postgres environment on GCP. They were not using Postgres as a managed solution, but rather Postgres running on GCE instances. So we created for them a whole architecture on Postgres, including all the components that you may expect from a production environment. Of course, high availability, automatic failover with Patroni. Thank you, actually. And disaster recovery, monitoring, alerts, and so all basically dimensions that you require on a production environment, Postgres production environment. So, what are the migration steps? What do you need to do if you want to do this by yourselves? What more or less is the guidelines? Let's go through those. The first one is to migrate the DDL. Actually, this could be complex, but in this case was very simple. Kind of. Nothing's very simple, but they were using Hibernate, which has its own advantages or disadvantages. The advantage in this case is that the DDL migration was trivial, because Hibernate did the most part of it. I mean, the application did require very few changes to work with Postgres. The bad news is that they were using Hibernate, but that's a different story. I'll not get into that today. So application required few changes. This is a takeaway. Thanks to the use of Hibernate, most of their applications were based in Java. And for the actual DDL migration, how to construct the Postgres DDL from the Oracle DDL, we used a tool called Ora2PG, which does also several other things, but it works very well for this part. However, this is not the output. It's not just running a single command and you're done. There's a lot of stuff you also need to do apart from converting the DDL. You need to tune it. There are some obvious things that you need to do and some of it that are not so obvious, and you actually need to inspect the data. If you don't care about performance, you don't need to do this, but they cared about performance. So, for example, what in Oracle is a number, by default it's translated as a numeric in Postgres. A numeric in Postgres is something very expensive, which supports arbitrary precision numbers, but in other words, very big numbers, and you typically have maybe integers or big integers there. So by knowing your data, you can go to more specific data types in Postgres, saving significant performance. And well, of course, timestamps. Timestamps are always painful, right? So this case, not an exception. So it required reviewing the use cases for timestamps and all the data types. Anyway, DDL migration did not take a significant part of the overall effort. It was part of it, but not the most significant part of the migration effort. There was also all the things to do to adjust permissions. Just bear in mind that Oracle has a different model where a user is a database at the same time, which is reflected as a schema. And well, in Postgres is much more flexible, where you have separation between schemas and users, and you can cross reference schemas with different users, and you need to basically readjust these permissions and assignments. Then there's also more path for optimization. For example, in Oracle, or typical implementations use triggers for things which in Postgres you don't require a trigger. For example, setting a default value based on a sequence. So instead of calling a trigger in PostgreSQL PGSQL, which actually will incur in a performance hit, you set it up as a part of the table definition, and that's faster. And of course, you can also use the occasion to perform some cleanup. In this case, there was performed data cleanup, index cleanup, identifying the indexes that are not being used, which is also a little bit tricky because even though an index is not used in Oracle, it could be used in Postgres or vice versa. You may need one index in Postgres that is not present in Oracle, might have been even ignored by Oracle Query Planner, but might be used in Postgres. So also requires a bit of work and effort there in trying to understand what's the query patterns and how they work. But of course, there are tools in Postgres. We actually used pgstat statements extensively for that, which is an extension that tracks record of the performance of the queries, and then you can get some information out of it. And finally, and this is required for the live data migration, which I'm going to be talking today significantly, you require kind of a way of identifying uniquely rows in a table. Typically, it's a primary key, and this is basically, to simplify things, a requirement. So we also needed to ensure that all tables have a primary key. They actually use this pattern where most tables had a primary key, which is called an ID, which is a number, which is probably a bad pattern, but at least they had this requisite solved. At the same time, there was one cool thing that we did here. There was a requirement from BBM, which is to partition the data. Data was not partitioned initially, and as you can imagine, they had tables approaching billions of rows, and it required already some partitioning to actually keep performance in a decent level. The good news is that, and I'll talk about later more about the process, but the logical replication was basically the technique used to replicate the data from Oracle to Postgres. And logical replication is more flexible than any kind of physical replication. And basically anything that is schema compatible between the source and the destination can work well. So Postgres will not care if the tables are partitioned, if they are compatible from a SQL perspective definition with the source data. So we actually implemented all the partitioning code for these relevant tables that require partitioning. This was Postgres 9.6, unfortunately. Unfortunately, because Postgres 10 and then significantly improved in 11, it came with native partitioning, which makes things significantly simpler and significantly faster. But it was 9.6 times, so we actually did a lot of coding for implementing partitioning and for being able to migrate all the rows for the testing environments. And there was also some data cleanup operation. So we started with something very simple, which is you run OR2PG and get DDDL, and we end up doing also a lot of work anyway in this phase. But other than that, as I mentioned before, DDL migration was not a really big part of the story. Then, of course, it comes to PL/SQL stored procedures. This could be a significant part of Oracle to Postgres migrations, and typically is like 80% of it when there's a lot of PL/SQL code in the Oracle database. This was actually not the case. They had a few triggers and a few stored procedures, so it was also not a big undertaking. However, you need to exercise a lot of care when you're migrating PL/SQL code. Because as I mentioned before, PL/PG/SQL, Postgres kind of equivalent, it is very similar, but it doesn't support the same features necessarily. And at the same time, you need to ensure that the behavior is exactly the same, which means you require to create prior testing environment, unit tests basically, to model the way this stored procedures in Oracle work, and then make your implementation in Postgres behave the same. And this not only includes the expected behavior, but also the unexpected behavior. You need to make sure that the errors produced by the code by wrong inputs are also the same, or actually being produced. So invalid inputs, you need to test for invalid inputs and valid inputs, and make a test suite to migrate the code. And then you're more or less safe in this migration. So this is the work required to do PL/SQL migration. It was also not a significant part of this. What is started to be more interesting is how to build a whole architecture on a non-managed environment, in this case in GCE, in Google Compute Engine. So being unmanaged has benefits. Basically, you don't depend on anything, you have a lot of freedom, you're not restricted, it's not a walled garden, but you need to do a lot of things yourself. And this includes a lot of things. One of the requirements, which anyway we work this way, but it was a client requirement, is that all the deployment needs to be fully automated, which means that literally by running a command line, you should be able to deploy a whole cluster of Postgres instances, replicating among them with replication, with monitoring, with HA, with everything. And this, you can imagine, is not a simple task. So just a brief description of the components that we used in this case. For the automated deployment, we used Ansible and a lot of scripting using specifically the G-Cloud API to call the Ansible scripts over the resources provision there. They were not using Terraform or equivalent by that time. And they were using Vagrant to test all these assumptions. So environment based on Vagrant to test all the deployment parts, and then deployment in production via the G-Cloud API. Postgres part, we also exercise a heavily tuned Postgres config file. Actually, I'm very interested in this topic myself. Last year's talk that I gave in this HighLoad conference was about configuration Postgres configuration. There's a talk called Postgres configuration for humans. And if you're interested in tuning around or learning how to tune 40, 50 parameters of the Postgres config file, feel free to check it. The video is there, and the slides are also pointed out there. So there was heavy tuning of the Postgres instances. Then they were using PG Bouncer for connection pooling. They were using Patroni. Again, he's one of the authors of Patroni. For automatic failover, automatic high availability. Consul as a distributed consensus data store, which is part of the HA architecture. And then Wall-E, very useful tool for backups and disaster recovery. And Datadog for monitoring. And actually, they were using this, have this connected to OpsGenie for alerts. So as you can see, a whole very production-ready, enterprise-y, if you want to call it that way, stack for Postgres. And that was also part of our work for this project. It looks like a little bit like this. I'm not going to get into the details because I don't know if you can see them all. But basically, there's separate zones in actually separate regions, which they were using for disaster recovery. And you can see on the top the console cluster that provided the consensus data store for the high availability part. And then the Postgres nodes using also a combination of a streaming replication and as a backup channel for the replication wall archiving, which is a well-known pattern that you should also use in Postgres for ensuring that replication has different ways of continuing in case of network failures and so forth. It is actually an architecture that can become quite complex. And it had a separate architecture for the data migration, which I'll show you later, which shows even more complex how it became. So let's look into the data migration, which is the most significant part of this project. How to do this, how to comply with this requisite of having no downtime, or almost no downtime during the migration. The only option, of course, is to do a live data migration. You cannot do downtime and then do a dump and restore of a several terabyte database and move it over the Pacific. That actually was tested, and it took like almost a day or something like that. So this is not an option. Even if it's hours, you cannot, in normal environments, you cannot do this. So what do you do? And actually, the tool Ora2PG, which is used in sometimes for this Oracle to Postgres migrations, only does this kind of migration. So you're out of luck. ETL, it's another option. There's many tools that would ETL from Oracle to Postgres happily, but this is also not a good option. First, because you typically would require to change your tables to introduce this created add, updated add fields, and of course change the logic of your program or implement triggers to update these fields. Actually, the updated add field conveniently, and still that will operate in batches, and these batches are going to have some lag. And actually, sometimes you'll either need to create also indexes to make these searches in batches to work well under your database, or perform full table scans, which are going to be very expensive. So it's going to be also lagging in time, expensive, and invasive. So not a good option either. So there's only one way left, and that's called change data capture. CDC, which is the process by where you extract data that is being changed in the database and you push in a stream of changes to the destination. In a way, I will explain with more detail. So, any change data capture process has essentially two different phases. A first phase, where you perform what's called the initial data load. The process is that the key in this process is that you find a point in the timeline of your database history. Could be arbitrary, but has to be one very specific point. And you commit to this point. And you perform some operations before and some operations after. So once you have chosen this point, then you can perform this initial data load. The initial data load is basically you take a snapshot of the database. This is kind of database dependent, but for example, on Postgres, it would be to create a transaction, a repeatable read only, or a snapshot database in a snapshot transaction in Oracle, and then you'll get the database frozen at that instant of time. Regardless of concurrent changes to the database, your view of the database will be frozen, and then you basically need to select from all tables. It's actually very simple. Of course, it becomes more complicated when you run it concurrently with several threads, dumping each different tables or even different parts of different tables. And this is typically required because typical scenarios have very large databases have very small tables or very large tables, but not intermediate tables. But anyway, the most important part here is that you choose this point in time, logic time in the timeline of the database, and then you perform the initial data load. And it's just freeze the database and then dump all the data there. And then you enable the change data capture by itself, which is the database or some external tool will provide you with the changes that happen since this instant of time. You can think of changes as insert, update, or delete. They will queue them, and then you will start processing them and applying on the destination after the initial data load has finished. And this will recover a whole image of the database. The database will be exactly in the same state as it was in the source. So, how do you do CDC? Well, I see some laughs here with Oracle Golden Gate. So, what? Oracle tool to migrate off of Oracle? Well, the actually is yes, it works. And in this case, BBM had a site-wise license, so there was no extra cost associated. A typical license of Golden Gate costs in the order of hundreds of thousands of dollars. But for them, it has no extra cost. So yeah, it works, why not? So this is kind of what the architecture looks like for the migration, which involves both the initial part of the architecture with the on-premise environment and the destination environment with Postgres and GCE, and all the pieces in between. It is well, it's a little bit involved, but it is basically an extension of what I've shown before. Now let me move on a little bit to give you a little bit more details about Golden Gate, because as I said, it worked well and it did the job, but it has several gotchas, right? The first one is that it's a pain to get it working. Basically, experienced Golden Gate administrator requires still full 2 weeks of work to get it working on this environment. And then, well, because actually, if you follow the slide, it says that the output was 12 pages of documentation with the commands in the specific order you need to run them and the config files you require for this to work. And actually, each test that you perform to see if this works basically requires sometimes like a whole data cycle to load it and then inject load and see the differentials, and then actually cleanup is very complex also. You need to clean a lot of stuff, and it's very manual. Actually, we end up almost automating Golden Gate in a way. I don't know if Oracle has ever done that. It is not meant for automatisms. It's meant for Oracle DBAs, and yeah, it's very, very involved, very involved. Actually, the most difficult part is that the Oracle to Postgres migrations with Golden Gate are almost not documented at all. Not even we actually bought a couple of books about Golden Gate. Almost no mentions to migrations to Postgres, unsurprisingly maybe. But there's not a lot of information out there. So actually, I'm going to give you some hints about how to do that, because we found no documentation, and that was also one of the reasons we wanted to do this talk, to help others follow this route. There's also a reason that it internally uses ODBC, and it uses a proprietary driver from a company called Progress, not Postgres, which has its own gotchas. Like, for example, timestamp with 6 will throw a very, very strange error. And you need to use just a simple timestamp sometimes. Very problematic. Now, the main gotcha is that this synchronization point I was talking before, the one that splits the part between the initial data load and the change data capture itself, the changes, is not anywhere explained how to get to this point. And actually, you need to do a query on the Oracle database to select this point and then inject it into the config files of Golden Gate, which you need to change dynamically to inject this point. And the way to perform the initial data load actually requires you to add extra hackish code to Oracle to say, hey, perform these queries as of SCN, which means go back in time to this logical point in time to get me the data as it was in that time, and so forth. It's very, very complicated. This is an example of how some of the config files look like. In this case, they look very, very simple. They are not, but I just wanted to show you this part of as of SCN, which basically means do this query in the past. This is called flashback query in Oracle. So, apart from this, there's a few extra steps to take here. Before performing the initial data load, you want to drop indexes, constraints, foreign keys to speed up the initial data load and restore them afterwards. We also created what's called a tombstone table, which is an indicator of when the migration process has finished. So once we stop the cutover time, we stop the traffic going to the source, we injected an indicator saying that replication is finished. And when this reaches destination, we know replication is effectively finished. Also sequences. Do not forget about sequences. They're not propagated by Golden Gate, so you need to migrate them manually. So you need to script this. We scripted this and basically provided some service that queries the sequence state on Oracle and then reproduces the sequence state in Postgres. We actually did the script such in a way that it will augment the numbers to a round number, so you can see where historically the migration happened just by looking at the IDs. Very convenient. Very important too, a rollback mechanism. What if after switching traffic to Postgres, it doesn't work well, there's a bug in the application, Postgres is not configured correctly despite all the testing, you want to go back? Well, you already wrote to Postgres. So we provided also a rollback mechanism that uses the same technique, but you don't need a tool for that in Postgres with logical decoding. And we were taking the changes happening to Postgres to a flat file in SQL format, which we could ingest back in Oracle in case we needed to go back. Fortunately, it was not needed. Yes, yes. Migration from Postgres to Oracle would have been significantly easier, but significantly more undesirable from our perspective. And finally, the big day came. The testing phase was actually very long. This replication with the Golden Gate was running for more than 2 months, so that BBM had the opportunity to test their application working in Postgres, to measure performance and to check that everything was working well. It was. And the final cutover day took place. All the cutover phases were heavily scripted. There were more than 80 steps, totally scripted with operators following step-by-step scripts that were basically typing all the commands and the operator is saying, yes, do step 1, yes, do step 2. It was tested like between 3 or 5 times, I don't remember exactly, before doing the real thing in production. And it worked in production. And the downtime that was basically contributed by the database, real downtime was 5 minutes, which is the time it took for the replication to finish. Once the writes were finished on the source, to all the remaining data to move from the source to the destination over the Pacific, to move the sequences, the tombstone, a few other checks that were in place. And then they also wanted to perform a real checksum of all the data, which started happening during the initial data load in Oracle in concurrent threads. And later, once the data was in Postgres, also concurrently in Postgres, and checksumming the data. That took another 40 minutes. So the total downtime for the database was 45 minutes, but could have been only 5. So this was within their maintenance window. It was announced publicly, and there was no user complaints. So that's pretty much the story. I think we have some extra time for questions. Thank you. Questions?
Thank you for the talk. First question is, does Oracle have HA? And if it has, so can we expect to Postgres to have that HA as well, not having another solution like Patroni or Stallone? And the next question is, like, there were for consensus there were 3 nodes. Did you set up it on different servers?
Yes.
And the third question is, you used vol-e. It was for continuous archiving, and what did you use for recovery? Thank you.
Okay, I'll try to remember the 3 questions in order.
I can remember.
So the first question, yes, Oracle had HA. They were using Oracle RAC for that. And Postgres has no native HA per se. But Postgres has great tools like Patroni for doing that. And even though it's external tool to Postgres, actually Postgres is meant that way. Most of you cannot run a bare Postgres installation and expect it to be production ready. You need to use many other tools that are part of the ecosystem to build a whole stack. It's part of the Postgres idiosyncrasy, I would say.
And currently, yes, but I mean, can we expect in the future, or they are not gonna to do that?
I don't think you can expect that short time.
So we need to install the Patroni. Yeah.
Yes. Yes.
Okay. Yeah, okay. And then about vol-e, what do you use any tool for recovery?
Yeah, I think you actually asked before about console. So yes, there were three nodes actually, but it's still recommended 5 anyway. And they were, yes, of course, absolutely. You need to do that in different servers, and they were actually running in different regions. Zones within the same region, but different zones. Each of those servers
should be different zones.
Yes.
Yeah.
Yes. Within the same region, the latency is very low. So you can do that, and in case of a whole, zones, not regions. Within the same region, different zones have very low latency, and you can survive failure of a whole zone. So that's why. And regarding wall E is used for backups, but it can also be used as a tool for disaster recovery, because you could basically copy. Actually, on GCS is very simple. You can copy the whole bucket to a whole new region. So with the archive data by wall E, you can move it over to a different region, and then it becomes effectively a DR solution or part of the DR solution.
And what do you do with PG-based backup in that case?
You don't need it per se. Wall E does a kind of a base backup by itself.
Okay, thank you.
It includes, if you want to call it that way, PG-based backup.
Hello once again. Have you ever considered use log miner rather than Golden Gate? Because in theory it should give the same stuff without paying for Golden Gate.
Well, there are actually many tools that do mining of the Oracle logs. We have had experience with other tools, and the experience is mixed. In general, not very good with many other tools. And the main reason is that they are mostly focused on many-to-many, so they support their tools are very generic, support many sources, many destinations, and actually Oracle to Postgres migrations become very specific. So we have had problems with many of the tools we have tried. In particular, LogMiner, I'm not aware of that, so thank you for the hint. I'll definitely have a look at that.
Thank you.
Thank you, actually.
What was the transfer rate between regions from Canada to Indonesia?
The effective transfer rate of the database or the available pipe?
I think bandwidth, the speed.
Yeah, it was very high, actually. I don't know exact numbers, but no of the process, no of the database or the other application migrations were limited by bandwidth at all. Latency is what it is, but actually that's one of the main advantages, I would say, of the Google Cloud Platform, is their network. They have their own network, they don't rely on the internet, and it's very, very fast. It was very fast. I remember, though, there were some problems at some point during the testing because they were not able to push more than 300 megabytes per second on a single thread. But then aggregating several streams of data, you could push more than that. I don't know exactly how much, but it was very high bandwidth. Yeah, and actually latency is still very good. 200 milliseconds to cross the Pacific, it is very low.
At the beginning of the talk, you mentioned that you kind of create tests for all the invalid inputs. How did you do that? Well,
I don't think I mentioned all. If I did, I was probably lying. Unless you would use something like TLA plus, it would be hard. But you require testing anyway, and you create this test from a reasonable approach.
So you just guessed what could be the reason. You just guessed what could be the reasonable invalid input. And
yeah, I mean, just think that after this kind of migration, the application needs to be tested heavily anyway. There's SQL, there's different behaviors of the database, queries might be run in a different way. The planner could choose to run a query in a different way. So you require a lot of application testing anyway. If there will be a significant mistake on a non-valid input, and actually you have the source code anyway, so you can see what the source code is doing. It's not that difficult. Probably it's not 100% correct, so there's no warranties of correctness.
Back to the Patroni, did you use any container or just you used VMs?
In this case, it was VMs. There was no, it was a technical decision. It was running on VMs. Yeah.
Thanks.
But there will be no significant difference on running on a Docker container. If you talk about Kubernetes, then you need to do something else. It's also, but that's, yeah, different story. And then you can ask here about that.
Would it be possible to perform this procedure without any downtime at all?
I mean, basically, yes. You could do this with very, very minimal downtime. You can call it seconds. But at some point, you need to stop traffic on the source. And since this replication is asynchronous, you need to wait until replication catches up on the destination side. The lag is normally a few seconds, even on this cross-oceanic link. But then you need to propagate the sequences. You need to propagate the tombstone, which is just a signal that the replication finished, and do some checks, additional checks. The check summing part of the data was totally optional, and actually didn't recommend it. But they had a maintenance window because they also had to migrate all the parts of the application, and actually even starting the application stack took minutes. So the database was definitely not a limiting factor at all. But yes, you can bring it down to seconds.
How you made all that physically? I mean, you don't sit with the same office with them, like, I guess.
Well, actually, BBM team is heavily distributed. They have 3 main offices, one in Canada, one in Indonesia, and one in somewhere else. And we were actually working from Europe mostly. But we met in person several times, and we did the internet works well most of the time.
Okay.
But it was a challenge. Communication challenge between the whole team. BBM required a team of almost 60 engineers for this project for 18 months. So communication was a challenge. Yeah.
All right. Well done.
Thank you.
Thank you for your presentation.
Thank you. Thank you for attending.